Hi guys, welcome to part 2 of a two-part lecture series on evidence-based practice statistics. Today we will be discussing the odds and the risk ratios, and so these two evidence-based epidemiological statistics sometimes are often confused and in most cases misused. And so I hope today that I teach you which statistic is most appropriate for the study design that you have or that you might be reading. After today's lecture, you should have a greater understanding of these two statistics, should understand their role in the epidemiological research, know how to interpret the results when these statistics are reported, but most importantly, in the older epidemiological research, when these statistics are not reported, you should be able to calculate them and really make inferences about that particular study's results. So what we know about odds ratio is this, is that we're really looking at the relationship between an exposure to something and an actual health outcome, right? So what we can say in this particular, let's say online lecture, is that the exposure will be taking some type of drug and our health outcome will be whether or not that patient suffers from a heart attack. Ultimately, what we want to know with the risk and the odds really is this. It's what is the risk of having a heart attack or suffering from a heart attack in those patients taking the drug? That will be our clinical question as we kind of progress through this online lecture. So again, the risk of a heart attack being the outcome in those who are taking a drug, and so that would be our exposure in this particular case. So as we progress through this lecture, I will be using terms like risk and odds, but I also wanted to just make note that in some research literature, when we're not talking about the ratio component and we're only talking about the risk, that the word probability can be used synonymously with risk. But when we start talking about the ratios, we should never use probability in replace of the term risk. So let's start with a very simple case scenario, right? Let's say, for example, we have 10 patients, and those 10 patients all took the drug. So that would be that green dot that you see in each of these patients' hand. Each of these patients take a pill, but only for some reason 6 of those patients suffer from a heart attack. We can get from this scenario is the calculation of probability and odds, or we could say probability or risk, right? So for probability, what we would say is that in the numerator, we would have 6 people who suffer from a heart attack, and that would go there. And we would divide that by the total number of people who actually took the pill, right? And our probability or a risk would be 0.6 or 60%. In other words, the likelihood of you developing or suffering from a heart attack would be about 60% in this particular group of patients, right? On the opposite end of that, we have the odds ratio, the odds. And the odds are a little bit different in that the numerator is the same, 6 people suffered from a heart attack, but the denominator changes. In other words, the denominator and the odds really represent those 4 individuals who did not suffer from a heart attack. We look at this number, we can say that patients who took the pill were 1.5 times more likely to suffer from a heart attack than those that did not. So what do we say about probability or risk versus odds? Really, honestly, the major difference in the calculation is that it's all about the denominator, baby, right? In the probability, what we saw is that it's the total number of patients. And in odds, the denominator only represents those individuals who did not suffer from the outcome or the disease, at least in this particular case, which would have been a heart attack, right? And as we progress and we start talking about risk and odds, we really have to start talking about study designs, because some study designs lend themselves to reporting the risk ratio and others lend themselves to reporting the odds ratio. So let's start with probably the most popular type of study, which is a cohort study. Cohort study could be prospective, it could be a randomized control trial, observational study, it just depends. With a cohort study, what we basically are looking at is this idea that you have basically an exposure, or you start with an exposure. In other words, a patient either takes the pill or does not, right? And you look over time prospectively to see whether or not those patients in those groups actually develop the outcome of interest. In this case, whether or not they suffered from a heart attack, right? So you start with an exposure. Either you have the not exposed, people who didn't take the drug, the exposed people who did. And you're just basically waiting for an outcome to occur, or for a patient to suffer from a heart attack or not suffer from a heart attack, right? We also have another type of research study, which is called a case control study. And in a case control study, it's the opposite of a cohort study, in that with a case control study, what you essentially do is you start with the outcome of interest. So in other words, you know if the patient has suffered from a heart attack or they haven't. If they've suffered from a heart attack, they're called a case. And if they didn't have the heart attack or the outcome, then they're called the control, hence the name case control study, right? And so what we do then is we look back retrospectively, right? And we see, of those who had the outcome, how many were actually exposed. And same thing there. Of those that didn't have the outcome, how many actually took the pill. So what we can kind of see is that these two different types of study really are going to require a different approach. And so it becomes instrumentally important to really appreciate that these two studies and these designs are different, and therefore that the statistics being reported should also be different for the most part. When we have a cohort study, what we want to report is the risk or risk ratio. And in a case control study, what we want to report are the odds or the odds ratio. And I will go into more detail in just a moment when we start our calculations. But for now, if you have a cohort study, then you should be reporting the risk or the risk ratio. And if you have a case control study, you should be reporting the odds or the odds ratio. Now, let us go back to the very beginning and let us just review before we move forward. In a cohort study, what we have is the exposure, so whether or not they took the pill, and we're looking for an outcome prospectively. In a case control study, you have the outcome. In other words, you know whether or not the patient suffered from a heart attack, and you go back retrospectively and you look at whether or not they actually took the pill. So what we can say about a case control study is that we're looking at the odds of people with the outcome having a particular exposure. In other words, the number of people with a heart attack who actually took the pill. But that's kind of not what we're looking for, at least not in this case scenario. What we're really looking for, you guys, is what is the risk of developing a heart attack in those taking a particular drug. And that really truly has to be answered with the calculation of a risk ratio, not an odds ratio. So let's start with the calculation of an odds ratio, and maybe let's start by first of all just discussing why we calculate the odds ratio in a case control study. In a case control study, what we don't know is the incidence in the exposed population or the incidence in the non-exposed population, right? So if we go back here and we're really looking at this case control study here, what we can say is we don't know what the incidence is in the exposed or the unexposed population. What we only have, or what we start with, are the diseased people, right? We know whether or not they have the outcome or they don't. Hence, in a case study, we can't really truly calculate relative risk directly. And that's okay. That's where the odds ratio statistic comes in. This is another measure of association that can be obtained from a case study. And so in the case that we do truly have a case control study, then the odds ratio is used instead of the relative risk. And so with that being said, let's just talk about how we calculate the odds ratio. So the odds ratio compares the odds of exposure in the cases, so those with the outcome, to those in the control, or those who didn't have the outcome of interest. And we want to know what the odds ratio is, how much higher are the odds in the exposure cases versus those in the control, or we could say how much higher are the odds of exposure in the cases versus the control. And as the term ratio implies, clearly we're going to be dividing the odds in the cases versus the odds in the control. So let's go back to our 2x2 contingency table, right? Everything kind of really always goes back there. And what we can say is that we have this 2x2 contingency table, and we can look at it two ways. We can look at it this way, or my preference is to look at it this way. So what we can say is that our columns represent those individuals who either had the outcome or didn't, and our rows represent those individuals who were either exposed or not exposed, right? So in cell A, for the cases, what we can say is in those individuals who took the drug, they had the heart attack or suffered from a heart attack. In those individuals who took the drug and didn't have a heart attack, that would be cell B. In those individuals who did not take the drug but suffer from a heart attack, that would be cell C. And those individuals who did not take the drug and did not suffer from a heart attack, that would represent cell D. So how do we calculate the odds in the cases versus the odds in the control? And so we would do that this way right here. What we would say is the odds of exposure in the cases is going to be the number of cases with the exposure, so that would represent cell A, divided by the number of cases without the exposure, that would be cell C. And then the odds of exposure in the controls would represent the number of controls with the exposure, so cell B here, divided by the number of controls without the exposure, and that would be cell D. So we have individual odds being reported. And so these are not ratios yet. In order to get the ratio, we then have to take the odds of exposure in the cases, which would be cell A divided by cell C, and we have to divide that by the odds of exposure in the controls. So that would be cell B divided by cell D. Now, if you're good with math, then you know that when you take two fractions and you divide them by one another, you create a cross multiplication product. And so the odds ratio would then be equal to cell A times cell D divided by cell B times cell C. So how do we interpret this? Once we have our numbers, once we get our odds ratio, how do we interpret the odds ratio? Well, we can look at it this way. If we get an odds ratio that's equal to 1, then the exposure does not affect the odds of the disease. In other words, you taking the pill has no implications for whether or not you have a heart attack or you don't, right? With the odds, if the odds ratio is greater than 1, the exposure is associated with higher odds of the disease. In other words, if you take the pill, then you increase your odds of suffering from a heart attack. Ideally, what we want is an odds ratio less than 1. What this means, the exposure is associated with lower odds of developing the disease. Another way to say that would be if you have a patient with hypertension or a patient with high blood pressure, same thing, and they are taking a drug that you truly do think would reduce their blood pressure, which would secondarily reduce the odds of them developing a heart attack, and they take it, and you look at the odds and the odds is less than 1, then you can say taking that pill reduced or lowered the odds of that particular group developing the heart attack or suffering from the heart attack, and that's protective in nature. We also see this reported in intervention studies where you're looking at maybe a rehab technique or an exercise technique. If that odds ratio is less than 1, then that exercise or prevention technique was really effective at reducing injury, improving outcomes in your patient. What you don't want is an odds ratio greater than 1, because in that case, your intervention, your rehab actually caused harm and did not do good or increase the odds of that patient suffering from an injury. So let us go ahead and actually do a quick case scenario. I'll do something again that probably spans across all 3 or 2 concentrations in our program. Okay guys, let's go ahead and take this case scenario here. What we're going to look at, interestingly enough, is alcohol intake. And we're looking at those patients who had greater than 80 grams of alcohol per day or ingested greater than 80 grams of alcohol per day versus those that ingested less than 80 grams of alcohol per day. And what we're looking at, or what we have in terms of cases, is we have individuals that actually had esophageal cancer and those that didn't. And so we can kind of take this case scenario and we can say we have a group of esophageal cancer patients who all come into our clinic. So we know the outcome, and then we kind of want to figure out, okay, what is causing this rampant increase in the number of patients that we're seeing with esophageal cancer? And so our clinical question probably might be, okay, well, maybe it's the amount of alcohol intake. So you can see how that's retrospective in nature, right? We have these patients who already have this esophageal cancer. Now we're trying to figure out what things could be responsible for causing this type of cancer in this group of patients that we're seeing. So again, this is a retrospective look at patients, right? And so what we can do is we can calculate the odds ratio because we have the outcome, but we just don't really know what the risk is. So we're going to calculate odds. Remember, we said the odds ratio is equal to the number of cases that actually had the disease divided by the number of cases without. So what we're going to do is it's going to be cell A times cell D divided by cell B times cell C, right? And so when we calculate this, if we're looking at the numbers in this actual table, what we can say is it's going to be 96, right, multiplied by 666, sorry about that number, divided by 109, multiplied by 104, right? And if you do the math, if you're doing it along with me, what you will see is that it will give you 5.64, right? And so what we said is that if you have an odds ratio that's greater than 1, what does that mean? Remember, it means that taking the pill or being exposed to something, in this case alcohol, is a risk factor. It increases the odds of you developing a disease. So in this particular case, what we can say is that an odds ratio of 5.64 suggests that there is a 5.5 that the odds are 5.5 times more likely that you would develop esophageal cancer if you ingest 80 grams of alcohol per day. Okay guys, so we've calculated odds ratios and we've kind of talked about what they mean and the implications for case control study should you have one. And now we're going to talk about risk ratios. Risk ratios are most often reported in a cohort study. However, again, you could potentially see them reported in a case control study as well. But let's go ahead and just talk about the interpretation of a risk ratio first. If the risk ratio is less than 1, then what we can say is that the exposure being considered is associated with decreased risk. So let's go back to our original scenario. If you took the pill, then you had a decreased risk of suffering from a heart attack. The risk ratio is greater than 1, then what we can say that the exposure being considered is associated with an increased risk. So in this case, taking the pill would increase your risk of suffering from a heart attack when compared to not taking a pill. If we get a risk ratio that's close to 0, close to 1, or is equal to 1, then there's no difference or little difference in risk between the two different exposures being considered. So how do we calculate risk ratio? It's a tad bit different than the odds ratio. When we calculate risk ratio, what we're looking at are across the rows. And so when we want to calculate the risk of the risk in the exposed group, then we would look at calculating cell A in the numerator divided by the total number of patients in that row, so cells A and B. If we want to calculate the risk of the risk in the unexposed group, then we calculate the numerator as C, so those that were unexposed that had the outcome, divided by the total number of patients that were unexposed, and we would get the risk in the unexposed group. However, just like with odds ratio, if we want an actual ratio, then what we have to do is we have to calculate the risk ratio by looking at the risk in the exposed group as calculated here, divided by the risk in the unexposed group as calculated there. So what we're going to do is work through a scenario that might be universal as well, and we're going to look at individuals who were taking a low dose aspirin and those individuals who were in a placebo group. So we know what the exposure is, right? This is more of a cohort study. So either they took aspirin or they had some type of placebo or they were a control. And what we wanted to look for is whether or not those individuals suffered from a heart attack or myocardial infarction, as some might call it, and those that did not suffer from a heart attack or myocardial infarction. And so as we look across the roles, we had 139 patients who took the aspirin that had suffered from a heart attack, 10,898 patients who took the aspirin and did not. In the placebo group, we had 239 patients who were in the placebo group who suffered from some type of heart attack or myocardial infarction. And then last but not least, 10,795 individuals in the placebo group did not suffer from myocardial infarction. So what I've done is basically in this column here, just totaled out the rows because I think it make it easier in terms of calculating. And so what we're going to do is exactly that in real time so you can see how that is done. So again, we have to calculate the risk, right? In the exposed group. So that would be the group that took the aspirin, right? So that's going to be the 139 divided by the 11,037 patients total. And then we're going to calculate the risk in the unexposed group, right? Because this is what's really truly going to give us our ratio for risk. And so again, that's going to be the 239 patients divided by the 11,034. So we have the risk in the exposed group being equal to approximately 0.0126. We have the risk in the unexposed group approximately 0.0217, and you can calculate those to confirm those numbers. We could kind of create these and make these percents, right? So we could say that this would be 1.2%, 2.6%, and this would be equal to 2.17%, right? And we could kind of say, okay, the group assigned to take aspirin here had an incidence of 1.2%, while the placebo or the unexposed group had an incidence of about 2.17% of myocardial infarction. But if we wanted to know what the risk ratio was, then we kind of have to take that a step further. And so what we would do is we would do exactly what we've done kind of sort of for the odds ratio, and we would say the risk ratio is then equal to that 0.0126 risk in the exposed group divided by the risk in the unexposed group, which was the 0.0217. And basically what we get is a 0.58. And so the question becomes, well, how do you interpret what this number means? So we would basically say those who take low-dose aspirin regularly, right? So it would be this group right here. Those that took the low-dose aspirin regularly have a 0.58 times the risk of myocardial infarction compared to those who did not take the aspirin at all. So in my mind, that's a relatively small risk. Another way to say it is that you have to make sure that when you are talking about risk, you always refer to the unexposed group. So we could also say those who take low-dose aspirin regularly have 0.58 times the risk of myocardial infarction when compared to those who did not or did not at all take the pills. And so remember, if we have a risk ratio that is less than 1, remember we said there's a reduced risk in the exposed group. So in essence, taking low-dose aspirin, if we were to interpret this, really honestly reduces the risk of suffering from myocardial infarction, at least in this particular group of patients. So calculation of risk, we have to calculate the risk first before we can actually calculate the risk ratio. And we can see that they are kind of similar in their approach in terms of odds ratio and risk ratio. One thing I would like to know is that when you calculate the risk ratio, you're really looking at the row approach. And when you calculate the odds ratio, we're kind of looking more at a columned approach. And so that kind of goes back to sensitivity, specificity, or positive and predictive values and negative predictive values. And so the numbers that you're using are going to be different. When you interpret your results, just make sure that you're interpreting them correctly. And if you always know exactly what it means when you get a risk ratio of less or greater than 1 or equal to 1, or an odds ratio greater or equal to 1, then you should be fine in your interpretation. So I hope that this was kind of helpful and that you maybe at least understand the odds and risk ratio a little bit better. If not, we will be doing some in-class stuff as well, just to kind of check your understanding. Anyways, thank you so much for listening to this online lecture.